Hello! Today in class we're going to solve some more examples in which we will apply the property of degree. First example. A fractional number 5/9 to the power of 17 must be multiplied by the fraction of 5/9 and divided by fraction 5/9 to the power of 16. In this example, we will apply the properties for multiplication and for division. We will apply the first and second properties. To solve this example, we can write each operation separately, but we can apply these properties at the same time. To do this, we need to pay attention to the base. The base is the same 5/9, so I'm writing down 5/9. Now we pay attention to what signs stand between our fractional numbers. In the first case is the multiplication sign, and that's the first property, so I have to add the exponents. And in the second case, I have to subtract. Let's pay attention to the exponents. The first multiplier has 17, but the second multiplier is written without an exponent. But you and we know the property that says that if a degree is not written down, it's degree 1. So then I'm going to write down that 5/9. In the power of 17, I am putting a plus sign because it's a multiplication sign. 1 and then the division sign. So by property, I have to subtract. So I write -16. And the result is 5/9. To the power of 17 plus 1, 18. 18 minus 16 is 2. I can leave it like that, but if we need to calculate, we can write that 5/9 is 25. 81. So, in order to solve the example and apply the properties, the first step is to look at the base of the degree. The second step, look at the properties that you're going to apply. Either add the exponents together or subtract them or multiply them. That's the example we're going to look at now, but if the exponent is written as a literal expression, can we apply the properties? Of course we can. For example, if I need to divide 9 to the power of a by 9 to the power of 2, then the rules say that I have to the exponential subtracted. I will write down 9 to the power of a -2. Let's pay attention to the exponent. We cannot subtract 2 from a, so the answer will be written as 9 to the power of a -2. Let's go back to this example and solve it in a different way. We're going to apply another property. I want to point out the base. 9 and 9, but 9 is 3 times 3. 9 is 3 times 3. And it's a number of degree A. We're going to divide by 3 times 3 to the power of 2. What do we end up with? 3 times 3 is 3 to the second power. Let me write down 3 to the power of 2. And this whole expression to the power of a divided by 3 to the power of 2 and again to the power of 2. Notice I've changed the base of the degree. It was 9. It's now 3 squared. We can transform the expression depending on what answer we want to get. But the answer is the same. It's just written in a different form. So let's solve it. 3 to the power of 2 and it's all to the power of a. In this case, we're going to apply the third property of degree to degree. And then we need to multiply the exponents. So I'm going to write down now 3 to the power of 2 times a. Divide by 3 to the degree of 2 times 2 equals 3 to the power of 2 divided by 3 to the power of 4. And then using the second property, write it down as 3 to the power of 2a minus 4. 2a minus 4. That's the way it's going to stay. So the answer would be 3 to the degree of 2a minus 4. But in this case, we got the answer 3 to the power of 2a minus 4. And in the first method, we got the answer 9 to the power of a minus 2. So we see that the answers are written differently. Let's prove that these answers are equal to each other. What can I do? Let's write 9 to the power of a minus 2 equals 3 to the power of 2 a minus 4. Why are these expressions equal to each other? I can write 9 as 3 squared and all of it is to the degree of a minus 2. And then the result is, using our third property, I'm getting out 3 to the power of 2 times a minus 2 and then 3 to the power of 2 a minus 4. I got the same answer. You can convert 3 to a power of 2 a minus 4. In this case, I can put 2 outside the parenthesis in the expression. 2 multiplied by a minus 2. 3 to the power of 2 is 9. And then it's 9 to the power of a minus 2. Take a note that we have proved that the entry denotes the same value. If you substitute any number in place of a, then the values of the two expressions are equal. That is why you can apply different properties when solving a problem using the properties of powers. As a result, the answer will be the same. In the next lesson, we will solve some more problems. That's all for today. Goodbye. See you again.